Hello and welcome to Physics 2212 Lab 4 Circuits by Blake Schwabe. The purpose of this lab is to use multimeters to measure currents and then using that to predict the circuit's behavior throughout. The system settings of this lab is the system itself is a circuit and the setting is everything else, and the results that we have, um, the loop rule and the node rule that we're going to be using extensively throughout this lab to find all of our answers will hold true throughout this lab, and there are many other results in this, so I can't just list all of them out for a preview of them. Important fundamentals and laws. Node rule. Nodes basically must be equal with a current flowing in and out of that node specifically. Then there's also a loop rule, so if you have a loop, the sum of all the electrical differences in that loop has to be zero. So all positive and all negative charges have to equal each other out. And then there's Ohm's laws, which basically is the relationship between voltage, current, and resistance throughout. Series and circuits, the prediction. So my prediction through this using what we have, I'm using Ohm's law. Basically having 147 ohms, basically having 3 voltage from the two batteries of 1.5 divided by 147 would give us an approximately 0.02 amps. And when we plug it in to our virtual model, because the real model I could not do, as shown there, shows 0.02, which is the predicted from the calculations we had on the previous slide. Now, here, what happens if the ammeter was inserted backwards instead of forwards? How would that basically read? So in this situation, up at the bottom one, I swapped them. I basically flipped it and inserted it backwards. And now it does not show any change from before, from the previous one. And then voltmeter replacing an ammeter. So what I did, basically following that graph on how to do that, and the result from that shows that the current now has 0.000 amps, and the voltage is negative 3V. The negative 3V is because there's no other part of the system that has a voltage drop, and since the voltmeter has a high resistance, the current will stay at a 0.000 amps. Series and circuits, conservation, voltage drop. So what is the voltage drop of the circuit along each separate part? So if you look in the bottom right, so A to B, B to C, and so on. So from B to C, D to E, F to G, G to H, and H to A, all of those are equal to zero voltage. V from A to B is plus 3 volts. V from C to D is negative 0.96, and then V to E to F is negative 2.04, which follows the loop rule, since 3 minus 0.96 minus 2.04 is equal to 0. This is the graph, basically plugging that all in to that will give us this kind of value. As you can see, the small drop at 0.47 and the bigger drop at 100. And why, when you touch the voltmeter, you alter the current, but why does the reading not change? It's because the ammeter has a very high resistance, so the current will barely go through that voltmeter. Now, when putting in parallel between an ammeter and a resistor, the current will go through the ammeter more because there is less resistance going through it. So now it only has 47 ohms, which gives us the 0.06 current. And now, basically calculating resistance, the only resistances we have are from the resistors, with the 100 being 102 ohms and the 47 being calculated as 48 ohms. And then here's charging. I did circuits, charging, and discharging. This is charging. I had a 10 and 20 bulb, and they gave around 11 and 22 seconds respectively. And same thing with discharging. Both of them gave the same amount of times for both. For the graph, I basically graphed out all of them using a stopwatch, and I got the observed slope and observed RC of 5.95, which is very close to 6. And errors that could happen were human errors from calculation mistakes and rounding errors, and then models are not perfectly predicting the real world setting. And what if we did this in real life? We use an actual ammeter that has an actual resistance, so there'd be slightly different results than the simulated lab that we had. And if we used a real battery, how would it charge in a model versus real life? Without a resistor, the model would instantly show it to be fully charged using the battery, but this would not happen in real life because the batteries itself has resistance in them.